This is section 7.03 of the Unit 7 notes, trigonometric ratios. Today I am, as in you are the student, discussing the three main trigonometric ratios so that I can calculate sine, cosine, tangent, and find the value for the side of a triangle. I will know I have it when I can solve problems involving real-world applications of trigonometric ratios. Specific techniques we're looking at for today's lesson is 6C. Use the Pythagorean theorem and special right triangle relationships to calculate distances. And 6D. Use trigonometric ratios to calculate distances and angle measures as applied to fields. Trigonometric ratios in the real world. Wherever there is a right triangle, there is a trigonometric ratio. So just to get you started with thinking about where right triangles or just triangles in general are located, look at these different scenarios or these different things in the real world that create right triangles. So for example, staircases, they create right triangles in certain ways. Sandwiches, they also create right triangles. Framework, in order for the framework to be stable, certain right triangles have to be made. Calculating different distances or different measurements using the location of an object and the location of another object and the angle that you can create from those two different objects. You can create a triangle based on those two different things. Same thing with the mountain. You're at the base of the mountain. You want to locate or you want to calculate the peak from the base of where you're at to that peak. You can do that given a certain amount of information without having to actually measure it with a measurement, a device, a ruler, whatever. Okay. Different triangles in things like boats that through physics lend itself to certain properties that boats can have when you use those things to sail in the ocean. Okay. Things like bridges, there are certain right triangles that you create in order for the bridge to be stable. So there are all different kinds of right triangles or triangles in general that you can see all throughout the world. For instance, if you look at your computer screen, you look at, usually computer screens are rectangle, by the way, or a square, whatever. But your computer screen can be cut in half diagonally. So if you take, if you go to the top right of your monitor and create a line that goes to the bottom left of your monitor, you've created a right triangle. And again, all these triangles that we see have different properties that are very useful to us when taking their measurements and figuring and solving problems that you're going to see in the real world. Like, for example, construction, architecture, geometry, all that stuff that involves certain shapes, certain sizes, can be solved partially through trigonometry. Okay, so these are just some examples of triangles in the real world. Now, what is trigonometry? What are trigonometric ratios? Well, first off, trigonometry is the study of how the angles and sides of a triangle are related to each other. So we're going to look at a triangle, mainly right triangles. If you don't know what a right triangle is, it's a triangle where one of the angles is a 90-degree angle, meaning this image right here. So a 90-degree angle. And we're going to be looking at different ratios of the sides of a right triangle. There are 6 that we study. However, there are only going to be 3 we're going to do in this lesson. And those 3 are sine, cosine, and tangent. Now, what does that mean? What does sine, cosine, and tangent mean? Well, all they mean is the ratio of certain sides of a triangle given a degree, given an angle that we're using as a reference. Okay, so what do I mean by that? Well, first off, before we go into sine, cosine, and tangent, let's talk about the makeup of a right triangle. So here we have a triangle, ABC, the different points, ABC. We have an angle. This symbol that you see right here is called theta, but it's just an angle, reference angle. And from this angle, we have different sides of a triangle. Now, again, from that angle, we have the opposite side, the side that's directly across from the angle. It's not touching the angle itself. We also have something called the adjacent, which does touch the angle. So across from it is the opposite side. Right next to it is the adjacent side. And the part that's always a diagonal, always a slant, that's what we call the hypotenuse. This one will never change. However, depending on where your angle is at, let's say it's up over here at C, then this would turn into the opposite, and then this would turn into the adjacent. So it's all dependent on what angle you're referencing when using right triangles, or when using sine, cosine, tangent, so on and so forth. Okay. So this is the makeup of a right triangle. And of course, one of the angles is going to be a 90-degree angle. More often than not, we're not going to be using the 90-degree angle. We're going to be using the other two corners when solving our problems here. Now that we've gotten somewhat familiar with the makeup of a triangle, let's start talking about the trigonometric ratios. The three that we're going to be looking at are sine, cosine, and tangent. Now the ratio for sine is using the opposite and the hypotenuse and turning it into a fraction. So for example, let's say the opposite side has a measurement of 5 inches. And let's say the hypotenuse is 12. And let's say our angle is 37. So sine of 37 degrees of this reference angle is going to need the opposite side divided by the hypotenuse. So 5 divided by 12 is the same as saying sine of 37. And again, this is just an example of what you're going to be seeing here. Okay, so again, sine of this angle is the opposite divided by the hypotenuse. We'll talk about what SOH means, but for right now, this is what sine of 37, or sine of the angle, means. Now, let's say we want to talk about the cosine. Well, the cosine references different sides, or at least one other different side, and that's the adjacent. So, for example, let's say the adjacent is 7 and the hypotenuse is still 12. The cosine of an angle is equal to the adjacent divided by the hypotenuse. Let's say the angle is 37 degrees still. The cosine of 37 degrees is equal to 7 divided by 12. That's it. That's all cosine talks about, is the ratio of the sides with a reference angle of 37. Tangent is the opposite divided by the adjacent. So let's say, again, for our example, 37 degrees is our angle, and we have 5 and 7 for the opposite and adjacent, respectively. So if I ask you to find the tangent of 37, I'm asking for the ratio of 5 divided by 7. And that's it. Okay, so when I talk about the sine, the cosine, and tangents of something, they're always in reference to the angle and the sides of the triangle that correspond with that specific ratio. Now, if all of this is a little tough to remember, I'm going to give you some things that may help with your memory on what is what. Some of y'all may have heard this before in geometry or at a different math class. Some of y'all, this is the first time to see it. S, C, T, the first letters of SOHCAHTOA, all represent what trig function you're going to be using. So S represents sine, C represents cosine, tangent, or T represents tangent. For sine, we're going to be using the opposite divided by the hypotenuse. So sometimes you may want to put a division symbol to kind of help you with memorizing. But SO represents sine opposite divided by hypotenuse. You may also kind of see it as S equals OH to know that sine represents opposite over hypotenuse. This is another way of just representing it. Moving on. That's so. Ka uses cosine of the adjacent A over hypotenuse. So again, the A and the H. C-A-H. Ka. And you can also rewrite it as C-A-H if you want a different way to remember it for cosine. And then TOA represents tangent with the opposite and over the adjacent. So T equals O over A. TOA. Oh, no, that's wrong. Sorry. That should be tangent. T-A-N for that part. Okay, so just some, I forgot what the phrase is called, pseudonyms or something. Maybe something else to kind of help you with memorizing what sine, cosine, and tangents ratios are. Okay, so now I have some examples for you. If you feel like you're ready to do this, go ahead and pause the video. Try this problem on your own. If you're on Class Kick, go ahead and fill these out. And I would also like you to calculate the decimal answers. So get the fractions, put them in your calculator, and get a decimal answer too. And type them in here. We have a triangle, and we want to find, in reference to angle P for this first one, the cosine of angle P. For the second one, we want the tangent of angle P. And then the last one, we want the sine of angle Q. So again, using our knowledge of sine, cosine, and tangent, see if you can figure out what the ratios are going to be for each respective triangle. So again, if you know what to do, or if you just want to practice on your own, go ahead and pause the video, try this on your own. Otherwise, I'm going to go ahead and go through this with y'all. So cosine of angle P, I'm going to be referencing everything to angle P. I need the adjacent and the hypotenuse. Because remember, cosine, and I have a little thing right here, SOHCAHTOA, cosine is the adjacent divided by the hypotenuse. So I need to use the 9 and then divided by 15, which, if I remember correctly, is 0.6. Yep, 0.6. So that is my decimal answer. Tangent of angle P, so again, still using angle P. Tangent, I want the opposite, so the side directly across from this angle, and then the adjacent as well, which is the side right next to it. So this follows TOA. Tangent is equal to the opposite divided by the adjacent. So this is 12 divided by 9, which, if we were to calculate this, is 1.3 repeating. So we're going to round it to 4 decimal places. 1.3333. And then the last one, sine of angle Q. So now my angle has changed to the other corner that we weren't using in the first two. So now the sine of angle Q is using the opposite, which is the side directly across from it, the 9, with the hypotenuse, which is always going to be the diagonal, 15. So 9 over 15 is equal to 0.6, which we've already calculated in the first one. And that's another thing I want y'all to notice. Look at cosine of angle P and then the sine of angle Q. Notice how the two different ratios ended up being the same depending on where you use those ratios on. So the ratio of cosine, adjacent over hypotenuse, is used on angle P, which means 9 over 15. And then if we were to use the sine of angle Q, we get the same ratio, opposite over hypotenuse, 9 over 15. So this kind of signifies that there's going to be multiple ways of doing the exact same problem. If you know your way around triangles, sine, cosine, and tangent, there are going to be multiple ways of doing the same problem. So I'm just going to be showing y'all one way to do this during this lesson. However, keep in mind there are going to be different ways. So if you find a different way that you can solve the problem, feel free to do so. Just don't be afraid of how sine, cosine, and tangent ends up working out, because it can be used any which way to get the same result. You just have to have the know-how of your right triangles and sine, cosine, and tangent. Okay, and this next slide just shows you the answers to it if you're on ClassKick. Now that we've familiarized ourselves with the trigonometric ratios, let's now look into a problem where we have some of the information on the triangle and need to find a different piece that's not known to us. So, excuse me. So in that problem, we're going to go through 5 steps to solve it. Step 1 being labeling the sides of a triangle, the sides of the triangle given to us to solve for. Step 2 is to determine which sides we care about when solving the problem. Step 3, which trig function associated with those sides will we use. Step 4, fill out the formula. And then step 5, solve by doing some math. Okay. Now, depending on what calculator you're going to use, it's important to make sure that your calculator is set to degree mode. If you're using Desmos, you're going to click on the little wrench icon and then look to the bottom and make sure that degrees is highlighted and not radians. Similarly, for the TI-84, if you're using that, click mode and you'll get to this screen right here. Look at the section where it says radian, and you want to switch it over and hit enter to change it to degrees. So again, just make sure that your calculator, whatever calculator you're using, is set to degree mode before we move on to the next part. Okay, so in this example, if you're looking at the triangle part, we have a triangle where one of the angles is 26 degrees. One of the sides is 47, and then there's an x value where we want to find that particular side. Question is, what is the value of x? Round the answer to the nearest hundredth. So, here we go. We have we know this is a right triangle, so that means we're going to be using some trig, one of the trig functions, sine, cosine, or tangent, and we know that one of the sides is missing, which will also help us determine which trig function we will use. We only have some of the information, and we want to find the missing value from this. Well, what do? So the first step we do is going to label the sides of the triangle. First, let's figure out what we're working with. Here's our reference angle, 26. The side across from that angle is our opposite. The side next to it that's touching the angle is the adjacent. And the diagonal is always going to be labeled as the hypotenuse. Now, after we've labeled the sides, which 2 sides do we care about? Well, the hypotenuse is going to be one of them. Okay, so the 2 functions that have the hypotenuse in it are sine and cosine. So we know tangent is now going to be one we consider. Now, the other side, the x value, is what will help determine which one we're going to use. And we notice that this x value is considered the opposite. So the only trig function where the opposite is considered and the hypotenuse is the sine function. So what 2 sides do we care about? Opposite and hypotenuse. What trig function are we going to use based on those 2 sides? We're going to be using the sine function. So now that we have most of the information, let's set it up and then solve. So step 4 is to fill out the values into the trig function. So sine of 26 degrees, the ratio of the opposite of hypotenuse with 26 degrees is x the opposite, divided by the hypotenuse, which is 47. So sine of 26 equals x over 47. We want to solve for the x value, which means everything that's attached to the x value, we want to move to the opposite side of the equal sign. Sine of 26 is a number, so there's nothing we have to do there. 47 attached to the x, we want to move to the other side and then calculate with the sine of 26. How do we do that? Well, notice this is x divided by 47. So what's the opposite of division? Multiplication. We're going to cross multiply the 47 across to the other side of the equal sign with sine of 26. And we should get the following, or at least get the following version of our equation. 47 times sine of 26 is equal to x. Now all that's left to do from here is to plug into the calculator and get our answer. We're going to round it to 2 decimal places. So whichever one you're using, sine, we're going to type it in, sine of 26 times 47. It doesn't matter where you put the times. You could have put it at the front, back, whatever. Is equal to 20.60. So 20.6 is our answer. If you want to figure out how to do this on a TI-84, just to show y'all the one time. Again, I'm going to make sure that this is set in degrees. Here are your 3 trig functions. I'm going to click on, well, again, it doesn't matter where you put the 47, but I'm going to type in 47 times sine of 26, and I will get the same answer, 20.60. Just to show you, if you have it in radians, 47 times sine of 26, you're going to get something completely different. So do not use the radian answer. Make sure you're only using the degree answer right there. And that's it. We found the missing side using our trig ratios. That's it for example 2. You try number 2. If you are on ClassKick, I would like for y'all to try this problem on your own. And of course, if you're not on ClassKick, I would like for y'all to go through the problem and follow the steps and see if you can get to the final answer. And again, if you're on ClassKick, you can move these boxes, check your work to see if you're following through correctly. And then, if not, of course, just correct yourself and see where it is you're going wrong. Otherwise, I will continue on and show y'all how to do this problem. So, similar to the example, what is the value of x? Round the answer to the nearest hundredth. I'm going to go through this pretty fast, so at any point you need me to repeat it, remember this is a video, just rewind it and listen again. So, 53 degrees is my reference angle. The side next to it is the adjacent. This side over here is the opposite, and this one over here is the hypotenuse. So, the value of x is my adjacent. So adjacent is important. And the 29 is the hypotenuse. And again, adjacent and hypotenuse are the important sides here. Which trig function involves both the adjacent and the hypotenuse? Sine, cosine, or tangent? Cosine would be that trig function. Now that I know what trig function I'm using, I'm now going to set it up. The cosine of angle 53 is equal to x divided by 29. Then going to cross multiply this and get my answer. So I'm going to type in cosine of 53 times 29. And round it to 2 decimal places, or nearest hundredth, 2 decimal places, is 17.45. 17.45 feet. Now I'm going to move these boxes just to show you what it is that I just labeled, or that I answered. there we go. And that's that. That's final answer for you try number 2. Now we're going to look at 2 other scenarios involving real world situations, and they're going to involve an angle of depression or an angle of elevation. So what do I mean by that? Well, pretend you're looking at something. When you look at something, you're creating a straight line from the point of vision to that thing you're looking at. So now, let's say you notice something either above on the sky or down on the ground. Well, if you look up, that's going to create an angle of elevation to the thing that you're looking up at the sky. If you're looking down, that's then going to create an angle of depression when you're looking down to that particular object. So again, just to show you on screen, when you're looking at something straight, if you look up, that's an angle of elevation. When you're looking down, that's an angle of depression. We're going to use those facts to create triangles and solve real-world problems using those triangles and values that we have from the problem that we have, from the given information. Okay, so let's look at example 3. A ladder. So normally when you take the quiz or test, I don't believe you will have this image. So you're going to have to be able to recreate the imagery shown in the word problem to understand where and what values you need to use and where they are. So a ladder that is 20 feet long leans against a building. So we have a building straight up, and this ladder is leaning across it. It's 20 feet. So we make that image. We know that it is making a 75-degree angle of elevation, meaning from the base up, there's an angle there. From the base up, there's an angle with the ground. So from the ground up, there's a 75-degree angle. To the nearest tenth of a foot, how far up the building does the ladder reach? So the top of the ladder to the base of the building, how far up the building does it reach? Okay, so that is our x value that we're trying to find out. I probably should have done this at the beginning. I'm going to pretend y'all did not see that. First thing we need to do is, after creating the image, is to label our sides. So from our reference angle, we know the opposite is this x value. The diagonal is always the hypotenuse. The side next to it is the adjacent. What sides do we care about? Well, we know the diagonal, the hypotenuse, is 20 feet, so we're going to find that. And then the opposite side, which is what the question is asking for, how far up the building is the ladder, is the next thing we care about. So which trig function involves those two specific sides? The sine, opposite over hypotenuse. So again, what two sides do we care about? Opposite and hypotenuse. Which trig function does that use? Sine. Now that we have all that information, we're going to fill everything out. Sine of 75 degrees is equal to x divided by 20. To get x by itself, we're going to cross multiply the 20 with the sine of 75. So multiply that to the other side. And we get the following before we solve: 20 times sine of 75 degrees. Plug that into your calculator. 20 times sine of 75 degrees is equal to 19.3. So 19.3 feet is our answer for this problem. How far up the building does the ladder reach? It reaches about 19.3 feet up the building. That's it for example 3. Scroll down and you will see the next example. You try number 3. Or not the next example, the next problem. You try number 3. So read through the problem, label your sides, figure out what two are needed to solve, figure out which trig function that's associated with, and then step 4, fill out the values to the trig function. And step 5, solve by cross multiplying, and you'll see what you need to cross multiply to solve this. Well, you may not. You may need some extra help, and if you need extra help, use these boxes to check to see what your work should look like when cross multiplying. Okay, so I'll leave it at that. See if you can figure it out. So if you're on ClassKick, or if you have your own piece of paper, pencil, and calculator, go ahead, pause the video, try this problem on your own, and see if you can figure out what you're supposed to do. Otherwise, I'm going to continue on and show y'all how to do this. So, an extension ladder leans against the building, making a 70-degree angle of elevation with the ground. To the top of the ladder is 10 feet up from the side of the building. So we know the side 3 right here is 10 feet up. To the nearest tenth of a foot, how long is the ladder? So the ladder is our x value, which is what we want to find out. We don't know what it is, and so the ladder, that diagonal, is our missing value. First off, let's create the image, which you see right here. Next, label your sides. We know that the side with 10, the side where it goes from the bottom to the top of the ladder, that is the opposite. We know the diagonal is always the hypotenuse. And then the side right here that touches the angle is the adjacent. What two sides do we need to solve the problem? We need the opposite and the hypotenuse. Which trig function uses those two sides? Sine uses those two sides. So now let's create our equation. The sine of angle 70 is equal to the opposite, which is 10, divided by x. Now we're going to cross multiply, except when we cross multiply, we're actually going to switch these around this time. Now, if you really want to know what math is happening here, I can show y'all. So basically, we multiply the x to the other side, and then we divide the sine of 70 to the right side. Cross multiplying, essentially switching around the places of those two things. Okay, and so we should get, and I'm going to move this box to show y'all, x equals 10 divided by sine of 70. So again, we're switching around, cross multiplying, and dividing this time. I'm not going to use that. Let's use Desmos. So 10 divided by the sine of 70. And we get 10.6 to the nearest tenth, 10.6. So 10.6 feet is the length of that ladder. And that's it. That's the answer for you try number 3. This next problem, this next example, so the previous problem was an angle of elevation problem. This next one we're going to look at is an angle of depression problem. Excuse me. So in this example, an electrician uses 9 meters of wire to join a junction box at the top of a utility pole. We'll pretend there's a box there. To a junction box at the ground level so that the angle of depression from that line right there is 55 degrees, which is 9 meters right here. 9 meters from the top to the bottom. To the nearest tenth of a meter, how far is the ground level junction box from the base of utility pole? So we want to know this ground level, this junction box right here, how far is it from the utility pole? So there's a couple ways that I see this going about. I'm going to show you one of the ways, and then I'll come back around and show you a different way you may have seen. Okay? But this right here creates a straight line with the angle of depression looking from that straight line to the bottom where that junction box is at, 55-degree angle looking down. Now the length of that line is 9 meters. We want to know from the bottom, that junction box to the pole, what is the length of that going to be? So one of the facts about angles is this. So if you did not know, this angle right here is the same as this inner angle right here. And then if we have something similar, this outside angle is the same as this outside angle right here. So using that fact with straight lines, with parallel lines, we can label this angle as 55 degrees over here as well. I'm going to show you a different way a little bit later, but here's one of the ways that was presented to us. Okay, so this is a 55-degree angle. Now, this pole, this line, and the ground make a right triangle. We know the line is 9 meters. We know this base, or this bottom right here, this x value is our missing value. So now that we've created our triangle with the 90-degree angle, our right triangle, let's label our sides. So in reference to this 55-degree angle, this is the hypotenuse, this is the adjacent, and then this is the opposite. Which ones do we care about? The hypotenuse and the adjacent for the missing value here. So to reiterate, what two sides do we care about? Adjacent and hypotenuse. Step 3, which trig function uses those two sides, sine, cosine, or tangent? The only one that makes sense is cosine. So cosine is what we're going to use for this problem. Fill in the values. Cosine of angle 55 is equal to x divided by 9. Cross multiply, we get 9 times the cosine of 55. Plug that into our calculator. 9 times cosine of 55 is 5 so once the nearest tenth of a meter, so 5.2 meters. 5.2 meters. Okay. So there may be another way to do this. Now I'm going to show you. Okay. So in case you were wondering, there is a second way to do this. Okay. This is a 90-degree angle. We know this is 55 degrees. So what angle does this make if this is 55 degrees? Well, let's, again, use Desmos. 90 minus 55, that's a 35-degree angle. So this right here is a 35-degree angle. We're going to use that as our reference angle instead. So this is still going to be the hypotenuse. However, the x is now going to be the opposite. So what two sides involve the opposite in the hypotenuse? Sine. So alternatively, we could have done sine of 35 degrees is equal to x over 9. And then cross multiply the 9 here. So let's test this out. Previously, we did 9 times the cosine of 55. And we got 5.162, or 5.2. We're now going to do 9 times sine of 35. and we get the exact same answer. Okay, so this is what I was talking about earlier in the lesson. There are multiple ways of doing the exact same answer. As long as you know how your triangles are, you know your stuff about triangles, right angles, degrees, sides, etc. It's all right if you do it a different way. Here's one of the different ways. Instead of using 55 over here and using cosine, I subtracted 55 from the 90-degree angle it created to make 35. Use 35 for sine, multiply the 9, create the ratio, etc. Kind of like this, except now it's sine of 35 degrees, and then multiply the 9 over there. And I got the same answer right there. So, either way is fine. Whichever one you feel is easiest to remember. But anyways, that's it for example number 4. Okay, you try number 4. Here's an image. We have a scenario where you have to find a missing side. And again, most of the time these things are not created. You have to draw up the image and figure out what the heck this problem is talking about here. So after you've created the image, label your sides, figure out which two are the most important, and then from those two, figure out which trig function you're going to use. Excuse me. Then after you've chosen the trig function, fill out the information, solve by cross-multiplying, and then get your answer. Okay, so if you feel confident, if you want to try this on your own, go ahead, pause this video, and work through it in ClassKick or on your own piece of paper and pencil. And then if you're on ClassKick, you move these boxes to check your work to see if you're doing everything correctly. Otherwise, I'm going to continue on and show y'all how to do this. Now, I'm probably going to show y'all 2 different ways. I'm going to show y'all the first way that's presented on here, and then I'm going to show y'all an alternative second way that may make more sense to some of y'all. Okay, but anyways, let's go through it. So a bird fountain that is located 12 meters from the base of Sam's apartment building. Okay, so from Sam's apartment building, that's 12 meters right here. There's a bird fountain. From his window, Sam can see at a 57-degree angle of depression, meaning his line of sight is straight. And if he looks down 57 degrees, he can see this bird fountain. To the nearest tenth of a meter, how far up the building is Sam's window? So we want to figure out how far up this X value right here is Sam in his apartment. So this creates a right triangle after we've given this entire image here. Okay. So if this angle is 57 degrees, then this angle is also 57 degrees. From our geometry knowledge of triangles, if this side is 57, so is this side. Okay? Now, we're going to label what our sides are based on that reference. 57 degrees, the X is our opposite. The 12 is the adjacent. And this angle right here is always going to be the hypotenuse. Now, which ones do we care about? We care about the X, which is the opposite, and we care about the 12, which is the adjacent. So, we only care about opposite and adjacent. Which trig function uses the opposite and the adjacent, sine, cosine, or tangent? Tangent is the one that uses the opposite and adjacent together. So tangent is what we're going to fill out into our trig formula. So the tangent of 57 degrees is equal to the ratio of the opposite, which is the X, divided by 12. So now we're going to cross multiply the 12. Since the X is on the top, we're going to go ahead and cross multiply the 12 to the left side and then just solve. And just so you can see what it looks like, here it is. 12 times the tangent of 57. Which equals, rounded to the nearest tenth, I believe, tenth of a meter, yeah, 18.5. So 18.5 is our final answer for U try number 4. 18.5. Okay, that's it for U try number 4, but now I'm going to show y'all a second way y'all could have done this. Okay? So, just like I was showing in the previous example, this is a right angle. We know that from those 97 degrees, this angle right here is 57. So what's the remainder? 90 minus 57 is equal to 33. So this right here is a 33-degree angle. Using that angle, 12 is now the opposite, and then x is now the adjacent. And then, of course, this side is still the hypotenuse. Now, this doesn't really change much in terms of sine, cosine, and tangent. Tangent is still going to be the one we use because that involves the opposite and adjacent. So we're going to use tangent of 33 is equal to opposite, which is 12, and then the x, which is the bottom. Okay? But now, notice where our values are located. So we're going to have to cross multiply and divide, meaning we're going to switch tangent and x's places. Okay, so this is going to go across each other, cross multiply and divide. Whereas before, we only had to cross multiply. But since the x is at the bottom, we have to cross multiply and divide to make sure the x is on top. So what will this look like? This will look like x equals 12 divided by tangent of 33 degrees. Now I'm going to type that in. 12 divided by the tangent of 33 degrees. And notice, top and bottom, exact same answer. 18.5. So that's one way you could have thought of doing this. Or another way you could have thought of doing this. And that's it. That's it for U try number 4. And that's it for Unit 7 or Section 7.03 notes in general. So if you have any questions, let me know. Use this video for your notes to fill out to help you study as a reference, or just rewatch it over and over again to help y'all understand what steps you should be taking when solving these problems on the quizzes and or tests. Okay, so that's it. I'll see y'all in the next video. Take it easy, everybody.